So here's a quick take on two different consensus methods in regards of blockchains. So let's get started. Let's talk about proof of work and delegated proof of stake, which I think are the most important ones because proof of work is the most known. It was the starter. It started with Bitcoin. And in my opinion, delegated proof of stake is the next step in the evolution of what a good network looks like, or a good consensus model looks like. Now it's no one. So let's say this is a ledger. Ledger. This is also a ledger. Could also call it maybe a database. It's essentially treat it like a database anyway. Then so yeah, proof of work. So we got in to explain how the ledger works or blockchain a little bit first. So you got a database essentially that has something called a block, which is like a container, which contains a certain amount of transactions. Can be 100 transactions. Usually it's like by MB. So blocks are supposed to have a certain size. And only so many transactions fit into that block or that container. But yeah, so you got a block, which is essentially just a container for transactions. And each container is linking back to the previous one. And that's how you can have a chain. Because, for example, in this block number 2 would be defined as the previous one. And then block number 1 would be defined as the previous one. And so, and then here you have 0 or null or the end, and it doesn't go further, but you can link back. And it's not by number, but it would be really by a hash, a very unique hash, which is looking something like this. And that's essentially the unique identifier for that block. And each block essentially says like that's in the ledger has a reference back to the previous one. So that's how you can keep a chain, because each block says, hey, the previous one of number 2 here was ASDJ whatever, a unique identifier, and that was the previous one. And then if you look it up, okay, it is this block, and then this block had a unique identifier for the previous one, and it was this one. So that's essentially like how you create or have a chain, or which makes it a chain essentially. So now that we know maybe what a blockchain is, now you got, in order to have a new block added into this database, you have miners. And the idea behind it is that in a proof of work network, or in a proof of work scenario, consensus model, you would have computers mine or look for the next hash, which is very difficult to find. It depends on the difficulty of the network. So let's say if you have 1,000 computers, it's very difficult to find the next hash. If you have only one computer, it's very easy to find the hash because you're the only person that essentially provides the computing power. So then in a proof of work scenario, the idea is that the difficulty gets increased as more computers or computing power tries to find the next hash. So the more computers are searching for the next difficult hash, for this hash, or the higher the difficulty. And if there are less computers, then it's well, easier to find the next hash. Once the hash was found and it meets that difficulty level that is required for the next hash, then it can broadcast it to the network, which let's make a couple more computers. Once a miner has found the hash, it goes to the network, and each one of them is checking whether or not the hash is valid. There's also a block being sent with the hash, which contains, or the next block, which contains transactions again. So let's say you have like 100 transactions in here with the next block. So you found, or one miner found the next hash. So it can have the next block added to the ledger. So, and then like this block with the next hash that also contains the transactions can be added to the ledger if it's valid. So the network is going to check, does this look okay? Is it valid? Is the hash valid? Is the previous block in the chain mentioned? Is that also the one that actually is supposed to be there? And if it's valid, then it's being added to the database, to the ledger as a new entry. Let's say this is block 4. So then we have like the 4th block added to it. That's essentially how it works. So, and then like the idea is that no single one can own the network, because as more mining computers join, the difficulty increases. So there's not a single computer that essentially can have all the hashing power and dictate what the next block is that goes in there. But rather it's supposed to be decentralized, because the more computers join, the higher the difficulty. Then with delegated proof of stake, it's a little bit different, because unlike proof of work, you do not need mining. So there's no mining. It's a little bit different. So I keep clicking on that, but I want actually this one. So let's say again, in delegated proof of stake, it's a little bit different, because you have allocated timestamps, or allocated time slots, not stamps, slots. So each one gets maybe 1 second, and that one can create the next block in the ledger. So let's see. Okay. So this one gets, and it goes in circles, can go in circles. That's one setup. So it starts with node 1. That one has now 1 second to broadcast the next block that's supposed to be added to the ledger. After that, this node is the next one that gets 1 second. And everyone knows exactly like which one is the active propagator or block creator for the time period, for exactly the second. So, and then once one of the nodes propagated a new block, so it gets validated by other nodes. So the entire network is then checking, is this valid? Is this block valid? Does the previous block hash match? Are the transactions valid? And if it's valid, then it becomes a new entry again here in the ledger that links to the previous one. So, but unlike here, in order to make sure that it is decentralized, you have user wallets with like a certain balance, like let's say 100. Let's take this one out. Let's say they're all 100, just for easiness. Then essentially each one is saying like, so which node is supposed to validate the transaction. And they can say like, for example, this one wants node number 5 to be their validator. This one wants to be node number 2. This one maybe says like, no, I want my representative or the node that makes votes in my regards to be the computer or the node number 3. And yeah, so each one can choose differently. And essentially, because they all choose differently, they have now, for example, 33.33 and so on goes to computer or node number 5 in voting weight. The same with number 2 and number 3, because 100, if you add it all together, that's 300. And for example, this user has 100, so that makes up 33% of that, of the total. And so this node number 5, has a voting power of 33%. So, or the vote of that node matters to 33%. Now, what you want in a delegated proof of stake, again, you want over 50% of the network to validate that the transaction, the next block, is valid. So in this example, we need 2, in this case 5 and 2, for example, to confirm and validate that block and say, yes, that is valid. And once those 2 validated and say in broadcast and say, yes, that's valid, it's being added to the ledger. So unlike mining, you have that with user balancers who essentially tell the network who is the delegator, who is the machine or node that is making a vote on their behalf with their balance. And then once you have over 50%, I mean, it depends on the project. It can be 51%, can be higher. It depends on the project. Once the majority of the network has confirmed or validated it and said, yes, this block is valid, then it's being added to the network. And that is what makes it decentralized. So there's not a single computer that can just add a block to it. No, it has to be the majority of the network. Now, the benefits of delegated proof of stake is you do not need the energy consumption that happens here and the slowness, because each block can have many transactions, but in the end, it still takes 8 minutes to get into the network. And oftentimes you want to wait several blocks before you can be really sure that there is no reversing happening, that the network is really, that the block is really like firm into the chain in the ledger. So, and we could also say like delegated proof of stake is just more efficient. It's faster because each node can have like a time slot of like a second. So you can have like every second a new block created by someone at different node. The other thing is also like, obviously you have some collusion through mining pools, because it's not as it used to be in the very beginning where computers would just like join and the difficulty would just get up and someone would get the reward eventually people came together and they were all mining under one mining pool. Well, not just under one, but they came together to mine under mining pools. The benefit of a mining pool is that a single computer does not have to try to find that, which can, at very high difficulty, take a very long time. It can take years, especially like if you have a slow machine, it can take even forever, way longer than just a year. So in that way, a mining pool is a service that helps those computers to get already a partial rewards for their work. So if someone like already did some work in trying to find it, they get a reward for it as well. They don't have to find the block hash, the next block hash, but rather they get already a partial reward for their work. So in that sense, but the issue with that is then you have the mining pool essentially containing the total mining power of all those 4 computers in this example. This is just to visualize it a little bit, to make it a little bit clear about how this all works. This is also why I think like delegated proof of stake is just way better. You don't have a lot of energy consumption. It is just faster, a lot faster. Like in seconds, you can have a new block in the ledger. So in that sense, it's just more efficient. And I also think that users are inclined to, they are just not incentivized to collude if it means that the network gets compromised or they're balanced. They can just choose whatever node they want or whatever validator they want. While in proof of work, a mining pool kind of, it incentivizes centralizations, even though like it's not meant to. But that's also why delegated proof of stake is just better. And in the long term, more decentralized than a proof of work consensus model. But yeah, so much to 2 different consensus models, but so much to that. And I hope you enjoyed it. I hope you learned something. And I'll see you in the next video.